plug here. It plugs into the wall. Okay? What you do, this is kind of fun, you fill this with oxygen gas, and then you ignite it. That's exactly right. That's the point. It will combust, it will burn. Okay? We essentially are going to burn your fuel. What's neat about this apparatus is what will happen, we'll have a very accurate thermometer that will be sitting in that water. What we can then do, when we burn it, that'll create energy, that'll create heat. That heat will warm up the water, and how much that water warms up will correspond exactly to the efficiency of your fuel. So if we put exactly 1 gram of your fuel, of everybody's fuel in here, we'll be able to tell which fuel burns the best by measuring how much temperature changes, essentially measuring how much energy is released by completely burning your fuel. It's pretty cool, right? Now, a little story about these. One, there's a lot of release valves on them, so nothing actually explodes. That's nice. But about 70 years ago, when they did this, they hadn't really made the design so nice. So what they used to do in chemistry buildings is they would have these like in an area angled outward and then like a breakaway window or something. Because every once in a while, if you didn't do the calculation right, pressure got a little too high, and this thing, went sailing. That will not happen here. This is a modern version of that. But it will give us a really accurate measurement of just how much energy is compacted into your fuel. I think you'll be surprised. It's pretty amazing. Just in 1 gram of biodiesel, which is going to be about that much biodiesel, that'll actually release a fair amount of energy. It's impressive. Okay. So that's kind of the overview of the project. I'll get into a couple specifics I want to talk about in just a second. Are there any questions at this stage? Yes?
Are we responsible for any of the thermochem calculations? Or?
No, but you can be if you want to be. So the question, basically you're asking, am I going to tell you the temperature and you'll have to tell me the efficiency of your fuel?
Yeah.
No. And essentially we're going to think of it in terms of just how much energy per gram of fuel. And in terms of doing that conversion, I'll be able to do that for you. But it'll track directly to how much the temperature changes, right? So a very simple approximation will just be whose temperature goes up the most.
Okay.
Right? But very good question. Now, if you want to do that, we can talk about it. Yeah. Any other questions about the processes?
How are we going to test this?
That's a good question. So there will be a couple of opportunities where I will bring this here, where you can bring in a couple batches of your fuel and we can actually run it and see how things are going. Now, but what is surprising is that how clear and essentially how pure your fuel looks will be a pretty good indicator. Because what is going to make a fuel less efficient is it going to be, does it have a little bit of water left in it? Does it have a little bit of glycerol left in it? Did you not completely convert all of the oil in your reaction? So those factors are going to be what contributes to this fuel not being quite as pure as it should be. And most of those will show up pretty well visibly. But that said, when it gets down to it, if there's you're not sure which one looks better, we can bring it in, we can test it. Okay? Yeah, good question. Any other questions about the goals here?
Well, you compared to diesel fuel, longer diesel.
I guess it could. You could do that. Sure, I could just bring some and burn it first. All right. Anything else you want to burn?
I just think that'd be cool to see how.
No, I'm not. I'm actually not being funny. That's kind of a cool idea. I like that idea a lot. That's a good idea. Yeah, we can see what it compares to in terms of the pumps. And also, interesting, you ever read on like a food package? It tells you how many calories are in it. How the heck do they know that? They burn it. That's right. So this is actually the process used to figure out the efficiency of fuels, also how many calories are in food, stuff like that. It's the exact same way. So I think this is going to be a really fun design. Now, the actual process itself comes with some instructions that I'll hand out here in the kits as well. But I want to draw your attention to two things in particular. One, so you use methanol as one of the reagents. methanol is not for drinking. Okay? Make that very clear at all. In fact, no alcohol, from your perspective, most of it, is for drinking. Very bad for you. But this will make you quite ill, possibly dead. So don't drink it at all. Yeah. It'll make you go blind first, too. That is actually true. Clear? Okay, good. As it says on this is a flammable liquid. In general, you should treat everything you're doing as flammable when you're making fuel, right? It burns. But this itself is quite flammable. So when you're using this, you have to be using this as well in a limited area. It must be done in a lab. You can't do this in your kitchen. Okay? This is one of the rules. That also goes with one of the other reagents that we're going to be using, and that is pure sodium hydroxide, otherwise known as lye. Okay, so this is NaOH in solid form. Okay, don't get any on you. If you touch it, you might rub your finger. You feel a little slippery. That's actually your skin dissolving off. What's that? They do still make soap with lye, actually. Yes. And actually, you might get a little soap as a byproduct of this. But soap is more made from fat, natural fat.